And good morning, everybody. We are almost done. Really, this is the end. We're going to go Monday through Friday, a test Friday, and then we are done, unless you're not caught up. So the next week, Monday, Tuesday, and Wednesday is just get caught up, okay? So we're almost there. So let's take a look at what we got. First of all, let's take a look at homework from Friday. These were isosceles triangles, so that if these two are equal, then angle J is congruent to angle M because they're base angles, isosceles triangle. If these two are equal, then angle M is equal to this angle, NK, hold on, LM. Oh, they're talking about LM. Just a second. LM, and LN. Then angle M is congruent to angle MNL. MNL. Interesting. Huh, I have that backwards. Okay. Same thing here. If those two angles are equal, then NK is congruent to NM. Okay, I got that. And if these two angles are equal, then LJ is congruent to LN. Okay. And then on the second page, these are easy. It's an equilateral triangle, so 31. That's got to be 60 degrees, so half of 60 is 30 degrees. X is 30, not 30 degrees. Yeah. And then 7, equilateral triangle, so then you've got, you get X to be 50, because if that's equal to that, then that's equal to that. Okay, and then the last one, X is 70 degrees, because, you know, in a triangle, 180 degrees, and take half of that, minus 40, half of that, okay? And then these two are equal. You already know X, so you plug X in and you can get Y, okay? So that's how you do those. Now, let's take a look at today's notes. We're going to skip 12.5 and put 12.5 with 12.6. So today's notes will be basically 12.6. But let's take a look. So today, what we've been trying to do is prove how two triangles can be congruent. We've looked at side, 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 but there are a few others, okay? So, side, side, side says if two sides of one triangle are congruent to two sides of another triangle, then the two triangles are congruent. So, this side's equal to this side, and this side would be equal to this side, and the third side is equal to the third side. You can say that these two triangles are congruent by side, side, side. We don't know anything about the angles, but we do know something about the sides. Angle, side angle is different, okay? And we also had a side angle side, which we learned the other day. Side angle side, and the side angle side is if two sides an inclusive angle, okay? So we learned that the other day. But angle, side angle, let's draw a picture of that. I'll draw this triangle here so you guys can see it. So if I got an angle equal to an angle, and I got another angle equal to another angle. Now the side is in the middle, so it's inclusive. What does inclusive mean? Well, it's got to be the middle, the side in the middle. Inclusive means it's got to be that side that we're talking about, because angle, side, angle. Can't be this one, can't be this one, because those are not inclusive, okay? So angle, side, angle, angle, side, angle. These two triangles be congruent by angle, side, angle. Okay, we looked at side, angle, side the other day. Draw a couple little pictures here. And again, the same thing with inclusive. You've got a side equal to a side. You get another side equal to another side. So the angle, the inclusive angle, the angle in the middle, would have to be that angle here, because it's in the middle of those two sides. It's inclusive. Now, hypotenuse leg, HL, stands for hypotenuse leg. Oop, leg, there we go. Well, hypotenuse means we're probably talking about a right triangle, correct? So, let's draw a couple of right triangles, okay? Here's a right triangle. Here's another right triangle, okay? Hypotenuse leg has to be a right triangle. Okay, so then you already know one thing, right? You need three things. You need three things. So you already got an angle, because if it's hypotenuse, it comes from a right triangle. If it's a right triangle, you already have an angle, 90-degree angle, and another 90-degree. Okay? Now, hypotenuse, it's along the side of the side opposite the 90. So if this hypotenuse is equal to this hypotenuse, we had a leg. Now both of these are legs, but one of the two legs, let's say it's this one right here, then we have three things. We can say these two triangles are congruent by hypotenuse leg. Finally, angle, angle, side. Now it's a little different than this. Very similar, very, very similar, very close, but not quite the same. Let me draw a picture. So, if we have an angle congruent to another angle, and if we have a second angle congruent to the second angle, okay? Now you need three things. What makes this different is the side could be here or here, but not the inclusive one. So maybe it's here, okay? So this one's a little bit different because the side we know is not in between the two angles, okay? That's angle, side angle. So we've got really 1, 2, 3, 4, 5 ways to prove two triangles are congruent. Now the one thing you cannot use, get up here, cannot use, okay, is the angle side side. Oh my gosh, that's a bad word, but you can't use the angle side side. Oh my goodness gracious. Let's go side side angle, so it's at least a little bit more appropriate. But if you see that, you know it's a bad word. This is not enough information. We're going to learn why this won't work in Algebra 2, okay? But this will not work, okay? Because there are several ways to draw the triangles, okay? Man, I'm sorry, you guys. I wrote it backwards. That's a bad word, which means it's a bad triangle, okay? Don't forget that. Okay, now, let's take a look at this, okay? Decide. Well, if I take a look at this, sure looks like this side is equal to itself. So I'd say, yeah, these two triangles are congruent by side, side, side. I've got a right triangle, but I don't know anything about the hypotenuse, but it sure looks like side angle, side to, oh, I don't think they're congruent because I don't know, this does not correspond to that side, so nope, that's, I don't know if those are congruent. In fact, they don't even look congruent, right? How about this one? Well, they share this side, that's a hypotenuse, isn't that a hypotenuse? I got a right triangle. So I'm going to say this yes by my hypotenuse leg, okay? 4. Sure looks like an angle, angle, side to an angle, angle, side. I say yes by angle, angle, side. Got the idea? Oh, see, this is that bad one. This is that angle, side, side. Sorry, you guys, didn't mean to write that. No, that's not true. That is no. We don't know. We can't use that one. It's a bad word, okay? Don't use that one. Most books write it like this for obvious reasons. Right? But that does not work, okay? How about this one? Lots of information, so I could either use my angle, side, angle, or my side, angle, side. I could either use either one, right? Whichever one you want. How about angle, side, angle? There we go. Okay, now, how about proofs? Okay, now we will not have a proof on our homework, or on our test, but I want to take a look at it because we will have it on our homework, okay? So, a proof. Here's how a proof works. Draw a line. So you have two columns, okay? It's called a two-column proof. Okay, and we don't have to be perfect on this, we just have to give it a try, okay? So, let's first of all, statements and reasons. Okay. So, step 1. Always write down the given. Let's see what the given is. AC bisects BD. AC bisects BD. Okay, I'm going to write that down. AC bisects BD. Okay. What else do we have? AB is congruent to AD. Okay, and AB is congruent to AD. Okay, the reason for that is it's given, right? That's like our evidence. So that's our evidence in a big trial, okay? Now, I like to mark my figure, okay? So that's equal to that. They already marked it for me. I like that. And then I'm going to say something about this bisects, because I know something that's bisected is cut in half. So I know that BC has to equal to CD. So I'm just going to say that. I know that because it's got bisected, okay? So step 2 in this should be that BC is congruent to CD. And the reason has to do with the bisector. It's definition of a bisector, really. Definition of a bisector. Because if you're bisected, you're cut in half, right? Okay, now, I need 3 things. You always need 3 things. Well, I don't call it 3 things. We need 3 sides or angles to be equal, okay? So let's just say 3 things. So I'm looking for a third thing. Well, what I notice is that they both share AC, right? So the third thing I'm going to say is this. I'm going to say, okay, AC is equal to AC. Step 3. AC is congruent to AC, and that's just because a line segment equals itself. Okay, so I'll just say that it equals itself. Or the book likes this word reflexive, and we're not going to get too technical. Okay, now, do we have 3 things? Yes. And what are the 3 things? Well, it's the side to a side, a side to a side, and a side to its side. So what I'm trying to prove, the 2 triangles are congruent. I have it now because I have my 3 things. Once you have 3 things of one triangle congruent to 3 things of another triangle, if it's one of our theorems, we're going to be able to say. So here's what I'm going to say. Okay, I can prove it now. 4, I'm going to say that triangle ABC is congruent to triangle ADC by what reason? Well, by side, side, side. Okay, we proved it. There you go. That's a proof. We're just going to practice these. We probably won't see these on our test, but it's good to look at them. Okay, one more proof. Let's take a look at it. Okay, same thing. Okay, start off with my 2-column proof. This is my statements. These are my reasons. Again, whenever I have to do a proof, first thing I want to do is write down all the given information. Okay, so the first thing I've got is, let's see, PS, that's this, is parallel to RT, okay? That should tell me something. PS, parallel to RT, all right, and I know PQ is congruent to TQ, all right, so what's the reason? Well, it's given. I mean, that's my evidence, right? It's my given. I was given that information, so let's write down given. Cool. Okay, now, I know some things. I like to mark my figure. I see that's equal to that. And I got parallel lines, right? Got parallel lines here and here. Okay, now, I need 3 things. Okay, so right off the bat, step 2, what do I see? Well, one of the things I see is because I've got parallel lines, right? Remember alternate interior angles? We learned that last chapter. I can say that angle S is congruent to angle R. We learned that about alternate interior angles. So I'm going to say angle S is congruent to angle R, and the reason has to do with, and I'm going to abbreviate, alternate interior angles, okay? AIA, or alternate interior angles. We know, see how it makes the Z? We learned that last chapter, okay? All right, what else do I know? Well, let's see. I have a side to a side, an angle to an angle, and I need one more angle. Well, I also know vertical angles here, or I also know that this angle here is equal to this angle here, because again, parallel lines makes the Z, right? So why not just make it easy? Let's say step 3, that angle P is congruent to angle T by the same reason, alternate interior angle. Or you could have done, if you wanted to, you could have said that this angle is equal to that angle by vertical angles. But we'll go for this one instead, because it's a little bit easier, because we just did it, okay? So now, do we have 3 things? Yes, what are the 3 things? It's an angle, angle, side, to an angle, angle, side. So we can say, once you get 3 things, we have it. We can say the 2 triangles are congruent by those 3 things. Okay, so step 4, unless it's the dreaded side-side angle. Okay, so then we can say straight to triangle PSQ is congruent to triangle TRQ by, what are my three things? An angle to an angle, 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 side, angle, angle, side, by angle, angle, side. Okay, those are proofs. Again, I'm not going to put those on the test, but I want you to look at them, okay? So homework. Today, page 351, 352, 1 through 8 all, there are a couple of proofs. I want you to just try them, okay? Do it your best. If they're not perfect, it's okay. It won't be the end of the world, but number 1 through 4, you just have to say what theorem makes them congruent or doesn't make them congruent. Number 5, I would draw a triangle. I really would, okay? So I would draw 2 triangles and I'd match them up and say, is that enough information? Okay, so for instance, if I look at 5, I'm going to draw a triangle LMN, LMN, and I would try and draw a PQR, PQR, and I would label, okay? They say M is equal to N, okay, M is congruent to Q, you got the idea, N to R, and L, and L, and L is congruent to RP, and you, okay, once you draw the picture, you can say, oh yeah, that's angle, angle, so I got the idea? Do the same thing here, okay? In the back, you've got a proof. If you know it bisects this angle, then you can say one angle is equal to another. And then you've got these two sides are equal, and I think there's enough to say, okay? On the trick on this one, if it's a circle, you can automatically say that this side's equal to this side because you've got radius of a circle. And you can even say that this side is equal to this side, but you got to be careful because you need more because that would just give you the bad one. So give it a try. I will talk to you tomorrow. It's our last week of instruction. We're almost done.